The broadcast is now starting. All attendees are in listen-only mode.
Welcome to Eccentric Mold and Engineering's webinar. If you're here for meeting time to market deadlines with complex insert molding, you're in the right place. I'm Connie and I'll be your host for the session. A few things to cover before I turn over our webinar to our keynote speakers. This presentation is expected to last approximately 20 minutes. Q&A is included during the presentation, so feel free to submit your questions using the chat function located in the lower right-hand corner of the control panel. Now I'll turn it over to our keynote speakers and have them introduce themselves. We have John Sidorowitz, Glenn Miller, and Darwin Rowe. Gentlemen, please tell us a little bit about yourself.
Thank you, Connie. This is John Sidorowitz. I'm the VP of Inside Sales here at Eccentric. Been with Eccentric a little over 9 years now. Have about 15 years of injection molding experience. Glenn?
Glenn Miller, tooling engineer. I've been with Eccentric over a year and a half now, about 25 years of injection mold design.
I'm Darwin Rowe. I've been at Eccentric for about a year now. I'm a senior project manager, and I've got about 25 years designing and building molds.
All right. And just want to thank everyone for joining this afternoon. We'll go over the agenda. And feel free to ask questions throughout the presentation. We'll try to answer them as we go. And additionally, we'll have a Q&A at the end. So agenda's up on the screen. This is what we'll be talking about today. Kind of what is insert molding, the benefits of it, some basic guidelines for standard inserts and custom inserts, things to consider when choosing materials for both the part and your inserts, and then file preparation for quoting. So with that, let's get going. So what is insert molding? So it's basically loading typically a metal piece, metal insert, threaded insert, into the mold and shooting the material or plastic in around those inserts, thus putting them in place. Opposite of that is heat staking them in after the fact, shooting your plastic part and installing them in. So what are the benefits of insert molding? First and foremost, it's going to reduce assembly or post-processing of the part. So you're putting the insert right into the part. Obviously, there is a small increase in cost to do that at the time, but it shouldn't be the same as heat staking it in post-process. On top of that, you get increased reliability, kind of meaning the insert's going to be in the same spot just about every time heat staking. It may go off center, or material may flow up and it just may not look right. You'll get consistency. And again, reducing size and weight of the part, and then you have some design flexibility. Anything you guys?
And absolutely, just reduction of any kind of secondary operation, adding a feature after the fact of injection molding, and then having to add that to your part for the assembly reduces the time.
Could also add a little bit of strength to the part too.
Right. All right. Some of the challenges of insert molding, kind of on the flip side. So, any type of post-processing like sterilization or alcohol baths or cleaning that come in contact with the metal, that could have an adverse effect. And then you also can have molding issues. So you need to add more material around those inserts. So bosses could create sink or warp, mainly sink opposite the opposite side of the insert where that boss is meeting, mainly because there's material behind that insert that we can't remove. Whereas if you were going to heat stake it in, you'd have a wider, deeper hole in that boss to remove that material. That's really the biggest thing.
Really, and if you just follow, basic design protocols when adding bosses and rib features to the part, again, we always talk about no more than 60% of the nominal wall stock of the part. That also falls in line with these inserts. You want to make sure you're not adding too much wall stock behind those inserts, which, as John mentioned, it can create sink issues and other issues that
Just some general guidelines for standard molded inserts. So typically you're going to find either brass, steel, stainless steel threaded inserts on the market. They'll be close-ended or open-ended. Kind of along the bottom there, we've got kind of a host of them. The biggest thing to look for, we can overmold typically just about any insert except the ones on the top right there. There's really no way to create a good shutoff or material flowing into those inserts, but everything below, it's really going to depend on torque of that insert and what type of insert you're going to use along with the plastics. So you can see there's a wide variety.
Various stages of knurling on the actual insert that provides the strength, as John mentioned, and also trapping that part into the plastic when it's overmolded.
So again, inserts should be rounded, no sharp corners. This is for material flow. The inserts, I mean, there's just a little kind of equation there. So they should protrude at least a minimum of 0.4 millimeter into the mold cavity. And this is going to help hold it in the tool. And the boss diameter should be roughly about 1.5 times the insert diameter. And in most cases, if you're dealing with mold-in plastic or mold-in inserts, the insert manufacturer will give design advice on how to design the ribs that it's being molded into. But the 1.5 times the insert diameter is a good measure to go by. Now, dealing with custom molded inserts, those are a little bit different, whereas with the standard, you're typically holding those inserts on a steel pin or locking them in place with a couple pins. When you get into custom molded inserts, it's a whole different ballgame. I mean, we've got a few examples here on the right of custom inserts that we've overmolded. And I mean, there's a wider range of things that you can. Magnets we've done, you just got to worry about them getting demagnetized. Most of the time those have to be post installed into the parts.
And the parts on the top with the tubular shape with the inserts, generally we have some sort of hand load with a wire that's pre-bent in that shape to make sure that the hand loads and the inserts are positioned properly, and that has to be consistent on every single shot. Otherwise you're going to get non-concentric inserts and things that are out of position.
Correct. So things to consider, the guidelines for custom molded inserts. Your shutoff's critical. We need a way to, first and foremost, need to have a way to hold the insert in the tool while plastic's being shot into the mold. So really can't have floating inserts or anything like that. If you're dealing with really thin, metal tubes, anything like that, you've got to have, ways to support that within the part so it doesn't flex or move during the ejection process.
And a lot of these threaded inserts have a pretty wide tolerance on the inside diameter, so if at all possible, it's always best to try to trap those in the tool for the cavity and core side. Sometimes that's not possible, but if there's a chance of designing your part that way, always a plus. Again, the tolerance, sometimes, as John used the term, float. We tend to make our locator pins for those inserts to the high side of the tolerance. And we do segregate parts at the press that are too loose and avoid using those. But the tolerance of the inserts itself sometimes can cause you some issues that will take a couple of adjustments to make sure they're nice and tight.
Right. And again, not just thin metal tubing, but small electric connectors, wiring too. Though the wiring can be tough to overmold, thin wires. If it's for a short distance, it can be done, but trying to coat a 3 or 4 inch section of wire is difficult, or try to embed into a wall or something like that. So just be aware when you're designing your part to just kind of think about how it's going to be held in the tool, and where it is held in the tool, that shutoff is critical. And as Glenn said, we might be running into flashing issues with the material or the insert floating or moving around in the tool and not being in the right spot. So part materials, again, kind of do your homework before, getting into your part design, thinking about what this part's going to do, how it's going to be used, where it's going to be used, and what it's going to see. So, if you're overmolding inserts, you want to use, materials with low shrink rates, toughened materials that have higher elongation and greater resistance to cracking. Because what happens is you mold in these inserts, and as the material shrinks around the metal is going to be stronger than the plastic, and the plastic will give and crack. So some good materials to think about are going to be nylons, polycarbonates, some bad polypropylenes and polyethylenes. Those will not be as forgiving.
You want the material surrounding the inserts to be strong enough to resist the torque put on those as you're putting the screw in or whatever, fasteners. So that's something to consider, of course.
And as far as insert materials go, like I mentioned earlier, your standard threaded inserts that mostly what we see are going to be brass or stainless steel. We work with ceramics as well. Most of the custom inserts that we've worked with, aluminum, copper, steel, magnets, ceramic, really just about any material that can withstand the pressure and the temperatures of the process, and really of the material that you're overmolding with. So, there may be some materials that can withstand, overmolding a ABS material where it may not hold up to something like a PEEK. So just take that into consideration as well. So kind of at the summary page here. So again, if you guys got questions, just feel free to submit them, and we'll get to them here shortly. Kind of going through the summary page, insert molding can reduce assembly and weight. Standard molded inserts, just ensure they're rounded. Depth of the mold about 1/6 diameter of the insert. Make sure the boss is about 1.5 times the diameter of the insert. For custom inserts, make sure you have good shutoffs or ways to hold those inserts within the mold during the injection process. And then follow the same tips for the standard molded inserts. For molding materials, again, look at low shrink rate materials, nylons, polycarbonates, ABS, PC ABSs are all good. And then for your insert materials, anything really rigid that can withstand the heats and pressures, mainly brass, stainless steel, ceramic, some copper, depending on the insert. And then, I think we missed a slide, but yeah, it looks like a slide didn't make it in. But when submitting a part for quote with Eccentric, make sure the inserts are in the CAD, so we can see where they're located within the part, and so we can quote properly. So essentially, it would just be an assembly file.
Also, if you have like multiple inserts going in to your part, maybe keep in mind the type of material you're going to use. So if you have like a high heat temperature material, the time loading the material, the inserts in the mold could be baking that material in the barrel.
That's true.
That's a really, really good point.
Give us a hard time to.
It increases the cycle time.
Yeah. Yep. That's a good point.
1 or 2 is fine, but when you get into parts that have 10,
15.
12, 15 of them, it really increases the cycle time and lets that material cook in the barrel. So,
It's good.
Okay, so let us know what questions you have for us. To start, do you supply inserts or does the customer do so?
Both. We can supply standard off-the-shelf inserts. We can CNC custom inserts from the customer's design, or we welcome the customer to provide the inserts themselves. So, good question.
Okay, Can I use any type of threaded insert?
Really, as long as you try to follow the guidelines, presented here as far as design goes, having knurling on the outside, and whether or not the inserts can be trapped in the tool properly, really depends on the application.
The solid design, diameter insert, not having slots on the side. A lot of them do.
Right. Tough to create a shut off there.
Yeah.
Okay, and our last question for the day. Can you overmold non-rigid inserts?
Yes and no. It's really
It does depend on the application.
Yeah.
If we're talking about wires, if the wires are connected to a board or other rigid piece, it can be done. It's a little trickier. Again, that really needs to show up in the CAD file for quoting to make sure we understand exactly what the application is and what you're looking for. You want consistency in the parts, so any kind of non-rigid material will cause some challenges, but it's case by case, and we can review that and do a DFM and try to guide you through that.
Okay, one more question. Are you going to share the presentation? Yes, we will. A presentation will be available out on our website in the webinar section, so we will have that out there and posted within the next 48 hours. Okay, thank you for joining us today. If you have any questions or interest in eccentric products, please visit our website, social channels, or contact us directly at the number or email listed on your screen. We thank you for joining us, and we hope everybody has a great day.